The goal of this video here is to build a 272 amp hour battery out of these Lithium cells, but knowing what else to put in there to make yourself a battery assembly that's going to be reliable is important. So I've built a few of these batteries before. I've got a couple of them, one or two of them up here on the channel. We wanted to do this one as a more long form of the steps we went through to make this, and I've done a couple of builds using this Plano box, and it fits these 272 Lithiums pretty well. And with the way that we're going to capture this with the wood and the hot glue and how it's going to be captured inside of the case makes it, in my opinion, something that is reasonable for a mobile application. So if you're going to be carrying this around at a campsite or throwing it in your RV or your trailer, with this you shouldn't ever have any problems with cells rubbing against each other and shorting out or bouncing around inside. Obviously, once you have them inside this box, whatever application that you put them in, you should probably strap that down somewhere or drill holes and mount that box to something. But that's what this video is a long form build of this battery. 272 amp hours at 12.8 volt nominal, lithium iron phosphate. Here we go. All right, so we've got our pieces of plywood cut with our appropriate slotting for our box. Caleb is now marking where the all thread's going to poke through the plywood, and the nuts and the washers will hold the battery in compression, primarily just so that it doesn't bounce around inside the box. These aluminum cased batteries don't call for compression as far as I can tell, but if they do expand and contract, you also don't want your terminals to be taking that load. You would rather your all thread and your plywood to be taking that load. All right, so now we've got the holes that the all thread will pop through, and we're gonna go ahead and take out these sections marked with the jigsaw. This will allow pieces of the wood to hit against the side of the box, but then we'll remove these pieces, which is where the terminals will come through to get from the inside to the outside for electrical termination. Then what we're gonna do here is just a little 1/8 bit into the box, just as a vent. That way, if catastrophe happens and those batteries do need to vent, you don't have a sealed box that they're venting inside of. Don't want to create a bomb.
No bomb.
All right, so next we're going to pop these into the holes right after we remount the holes. So with each of these, between the two black pieces, you'll notice that they had like this ceramic plastic stuff. So if you were doing this in a metal box, you could actually drill the hole the size of this black piece right here, and then these would fit so that the metal stud never contacted the box. Since this is plastic, that's really kind of unnecessary. What I do is I flip this backwards. Yeah, whether it's backwards or not, I don't know that it really matters, but...
Did I grab the wrong bit?
No, it's just tight. It's a 3/8 bit with a 3/8 stud. Mr. Ceramic piece. And then this is gonna be the nut that we will tighten so that this assembly is tight. Now, something else we need to pay attention to, how far down this turns before it bottoms out. So like this seems pretty good. It's bottoming out right about there, so you can see, but once you put something in there, a lug, a ring terminal, that it's not gonna bottom out. So you don't want so little threads that it can't grab on much, but you don't want so much that even with something in there, it won't actually tighten. So something to pay attention to. So we're going to tighten up this nut here to secure the assembly in the box. So hold this and tighten up that nut. The big deal is that when you go to, when you get that super snug because you don't want your terminals loose, and you go to loosen it, does it loosen the inside? Yeah, so it loosened up, didn't it? That's the hard part about holding this when you do the nut on the other side, is because then it gets caught. So if you can hold this and then tighten up this side. So there's one. Squeaky tight. All right, well that gives us a complete battery box. Now it just needs a battery. Next, assemble the battery in a way that it is one piece. What we've done already is you saw us put hot glue between each of these cells, and that's primarily so that once we have them captured within the all thread and the plywood, that they can't slide on each other inside the pack. You'll notice that we put some slots in these pieces of wood so that when these fit in here, they won't be able to slide side to side. because there's this rib here in the battery box that will prevent that this is on. So that's gonna be our method for keeping things where we want them to be, but that only keeps the plywood in place. And since we're compression fitting the plywood against the cells, that could still slide around. So each of the cells has hot glue, and then we'll put some hot glue on here before we capture the batteries, and that will keep them all as one unit. All right, we messed up. We were trying to be smart. We were like, hey, let's put notches in the board. We'll have to install a negative terminal after dropping the battery in, because otherwise it won't clear. But that's okay. It's up top, so we can do that.
I found a ratchet. Well, we failed on that front.
Where are we failing?
I measured my measurements. Didn't work very well.
You're now performing the walk of shame back to the cutting board because our holes are too close together. We are a little cross-eyed right now. So we're just gonna re-drill one of them, remarked. One set, yeah, for the side that's got the more space. Yes, you'll note that we have threaded rod running through a battery, and we're going to put some black tape on that here in a minute. Oh, you got it down pretty good there. We're at the warehouse right now, surrounded by panels we have yet to fix or are just standing there because they're busted and we ain't going to sell them to anybody. We've got some 350 watt panels that someone was purchasing earlier. Got one more pallet of those before they're out. We'll have some 310s in here probably by the time this is released. We've got some 400s over there that we've promised to people, but we need to get them repaired first. Now we have some insulated threaded rod. So if these rods are gonna fit, then I guess the next piece is gonna be throwing some glue, some hot glue on these puppies. And I don't really expect this glue to keep things from coming apart. I expect the glue to keep things from sliding around on each other. We want this battery to act as one piece instead of 4 different pieces. I don't know if I mentioned it, but one of the big reasons for that is if these batteries do swell a little bit, which you're not supposed to have compression for these batteries for swelling for performance reasons. But if you've got a bus bar here and you've got those nuts tightened down and these cells swell, then you're gonna be putting tension on these terminals. And I know I don't want tension on those terminals. I'd much rather tension be on a threaded rod.
Hot glue this side? Or did you hot glue this side?
I don't remember. I don't know if it would matter. You don't need much. Yeah, I just do a little strip.
Just do a strip?
Maybe. I think I did it like on the edges because the plywood will naturally bend and not really contact much in the middle anyway. Yeah. You got plenty of space on this side.
Oh, crap.
Redo?
Yeah, that's too much. That's touching this side, isn't it?
I mean, you still got some clearance.
Got some clearance?
It could be okay.
Side on tester fit.
May as well.
See if we're okay with that.
That's the hard thing with this hot glue is like once you get it on there, like you have one chance
Oh yeah, that'll work.
to get it right.
You're right, that'll work. If I put that in there, I should be good.
Yeah, we got some space. So even though we're insulated, we wanted to leave some space between the threaded rod and the cells, because obviously if you have a metal rod here and that managed to hit multiple cells and the outside of these cells are the negative terminal, then you could get a short across the batteries, across the cells inside the battery. Doesn't that look beautiful? And I'll say it's just plywood. What's so special?
Maybe next time I'll spray paint, we can paint them.
Yeah, I told Caleb when I got here, it's like I should have brought some.
It's a problem not doing everything at home where you have.
Yeah, because you know, I've got spray paint sitting in my garage somewhere.
So how tight are we doing this here?
Not super tight. It's just if we can like see the plywood starting to give a little bit, maybe that's probably
so I got
good.
a little bit of gap right here.
I don't know that we're gonna make that up or not.
I saw it move a little
really?
bit earlier, but.
I don't want to over tighten them for sure.
So you want us to do plywood bend just a smidgen?
That's what I went with. Okay. Last time.
Kind of feel like that bent a little bit that side.
Yeah, I can see a little bend on this one. So now we have an assembly that weighs a little bit.
Okay.
I forget what this weighs. It's like 50 pounds.
Dang.
I think like 5 kilograms a piece. That might be like 60 pounds. I'm not good on metric to American conversions, but it's about 27 kilograms. All right, so the next piece here, Caleb's looking for some 2-gauge red wire. Oh, look, some 2-gauge red wire. It's almost like we expected to need that. This might be a little overkill for what we're doing here. We're gonna be putting in a 120 amp of BMS, so I've often used 4-gauge welding wire. This is what this is called, the super high count copper think this is Windy Nation stuff, which I like the quality of their stuff. Yeah, welding and battery, 600 volt wire there. 2 gauge. So we've got, these look like 4 gauge. That looks like 2 gauge. So we've got some 2 gauge lugs here. We've got one that's a 1/4, which will fit our M6 studs on these cells. And then we have this one, which is a 3/8, which will fit our studs for coming out of the battery. So we'll need an end of each of those, and then our nice heavy duty crimper. And I think we've got a 4 gauge in here, but we'll need a 2 gauge die for this guy. And did we grab our big wire cutters? Because those worked okay as strippers. There's one tool I don't have is a good stripper for heavy gauge wire.
This is not what you do at home.
Pretty.
Give us a little test fit.
Yep.
I feel about right.
Cool.
I have yet to actually use this, so I'm going to make some assumptions.
So far, so good. So what I normally do is I grab this, I stick it in where it's just right there,
Okay.
and get it snug before I grab the wire.
So I pop my finger in there and kind of.
Yeah, this is the hard part. I usually like sit on the ground and hold it between my legs, but that'll work. I will hold this in so that you can do 2 hands on the crimper.
Is there a stopping point we're going for here?
Probably, but I am not an expert on that. It'll certainly stop.
It gets harder, harder,
It's a little snug. Yeah, I mean, it's hydraulic, so it's basically when it won't go anymore. I think you're good. Yeah, you're good.
Okay.
So do that to release. Turn the, yeah, there we go. Now, so it even punches a little 2 in there, showing it's a 2 gauge.
Nice.
You can tug on it and see if it's tight.
I'd say so. All
You
right.
could throw some heat shrink on this puppy.
Heat shrink. All right.
So you probably want to run it to like here. You don't want to get heat shrink on the flat surface here, because that's going to be making contact with like a washer or something, right? Look at your handiwork. All right, so now we want to stick it in the box and see how long we need this wire.
Probably come in like this.
Yeah.
Then come back around, and the battery, we're
Right
going
up in
to the positive, which is this one.
Yep. So yeah, I think something like that.
Now, is there a reason we're using copper and?
They're both copper. This is tinned copper.
Oh, okay.
I'm sure it's just because I bought it at a different time on Amazon.
Seems like a logical reason. Okay. We're not covering out the flat part. All right.
All right, so now we can go ahead and
Attach
this in. That way we don't have to do it after the battery's in place.
All right. So we're doing a washer on both sides of it.
Yep. It should allow us to tighten it down without causing too much stress to anything else. The washer's let it slide. Oh, look at that, she got this perfect.
Looks like I got it tight enough earlier that I may not have to have a tool on this side.
Oh, nice.
And that feels good and tight there.
All right, so our next part is going to be getting our syn sleeves ready for our BMS. So make sure that when you're working on this, you have your syn sleeves disconnected from your BMS. You don't need those connected. What we're gonna do is go ahead and strip a little bit of extra wire off of each of these syn sleeves. And that's because these ring terminals that we have are 22 through 16 gauge. And BMS syn sleeves are typically more like a 26 gauge. So they're a little bit small of a wire. The problem is finding something with such a large hole, like an M6 or a 1/4 inch hole, that has such a small wire that would be attached to it. Because logically thinking, you would never send that much current through an M6 connection. Like, why would you have a wire that can be rated for so little with such a big connection? So I think that's the reason for it. So these are 22 gauge. We probably got 26 gauge wires. What we're gonna do is strip a little bit off so that we can double over on our wire before we stick it into our ring terminal, and then we will crimp using our ratchet crimpers here on the smallest setting. So if you look at the bottom part here, you can see this is the part that's supposed to be the actual crimp, and then this is where the insulation piece or the heat shrink would sit.
Okay.
So just like you're holding it right there. And these here are heat shrink ring terminals. which are a little more expensive, but seems like a bit of a nicer product.
Almost like I got a little too far. It's almost
Is
good.
it loose? Does it pop back and forth?
It popped at first, but then it got right in place. It ain't going nowhere now. I'm gonna go ahead and do this here because I don't feel like I got the center of it. Oh, it's moving on me. I don't think I crimped it correctly. It slid on me over to the back side of the crimp. I didn't get the center of it. And then when I was testing it, it pulled out just a hair. So then when I fully got it crimped, I don't think it got fully on there. So
that makes sense.
That feels much better there. I'll make sure I get this more front loaded. Make that more center, and we'll see how that feels. Yeah.
You always want to test it, make sure that your crimp is strong. When we include these in our kits, I go ahead and include at least one extra ring terminal in case you do mess one up and you need another one. So we're just gonna run through here real quick and strip a little wire, double it over, and do your connections. So each of your BMS leads, so these have a black and a red and then 3 whites. The way BMSs read a battery is black is your main negative for the battery, and also it reads, in my sense, backwards, because black is not the first, right? Red is the first. But if you're ever looking at the app and seeing, okay, what's cell 1, cell 2, cell 3, cell 4 for here, right? The one where the black lead is connected, which for us is gonna be this cell here, this is gonna be cell 1. So cell 1, 2, 3, 4 across the board. So if you're ever wondering which one's which when you're looking at a BMS and maybe you're troubleshooting a battery and need to see what's the voltage of a certain cell, that's how you would know. Black lead goes to cell 1. And there are 5 wires here, but 4 cells. That's because you start with a negative, and all the other wires are going to be sitting on the next positive terminal. So you get your main negative here, your first positive sense lead here, and then your second one here, third one here, and fourth one here, which is also going to be your main positive. So that's why there's 5 leads, because you're going to start with your main negative. It's really not too difficult if you have this process in front of you. I think even being super careful and taking your time, if you've got all the tools ready for this, it shouldn't take more than a couple hours to put a battery together. Keep in mind, this is 272 amp hours, so if you're looking in comparison to like a Battleborn, those come in a 100 amp hour. So this is what, 2.72 times the capacity. If you want to get these cells from us locally, we don't have a way to ship right now for these big old battery cells. But if you want to get some of these locally, we can get you a deal and you can be able to put together a battery that's going to have more capacity than your commercial batteries. And you got to build it yourself. Most of those batteries also don't have Bluetooth communication like this one does. And there is an iOS and an Android app that you can use to connect to this and monitor the voltage, monitor the current that's running through here, turn on and off charging, discharging, all those things. Set the actual protection parameters. I know in the iOS you have to pay for an upgrade on the BMS software in the phone to be able to change settings, but you can actually go in there and change what your protection parameters are. So how much current you want to allow through it, what your max voltage is, your lowest voltage, your under temperature protection with the temperature probe and whatnot. Let's see how well these terminals heat shrink, huh? I suppose they are made for 22 gauge wire, so it would make sense that the heat shrink isn't quite making it onto the wire. Looks like it
pretty close.
Looks like it got really close. So next piece, we're going to get our studs and our bus bars onto this battery here. These studs do have an Allen head in them. I'm a bit torn because the idea of having an Allen head in the stud would be that you can hold this stud still while you tighten the nut down. But if you're doing that, then you can't use a torque wrench, because the only torque wrench I know of is a socket-based torque wrench. Anyway, we don't have to have them like super tight or anything, but just in there, because as soon as we put the nut on and start turning it, it's either going to turn the nut on the stud or try to turn the stud into the battery. And that is something you don't want, right? You wouldn't want to stick an Allen key in here and just torque this into the battery, because that would poke into the cell itself. There's only so much aluminum here before you hit the cell. So I know the last one I did, I actually would put them all the way in and then back them out like a quarter turn. That way, hopefully, the nut is screwing on the stud instead of the stud trying to go putting pressure on the bottom of the terminal. These are all grade A cells, so all of our terminals so far have been perfect. Unlike some cells you might get from Alibaba or AliExpress, where they were pulled out for dents or scratches. They've been rewrapped. They had retapped holes or anything like that. These are grade A. They've got their QR codes intact. They've each got a label on them for the resistance and their voltage and everything being checked. And everything that I've tested here has been up to capacity, which for these is 272 amp hours. So now that we've got that, now this we've already determined is our main negative. So we need to stick a bus bar here and one here and one right here. So just the 3 bus bars. And then what we need to do is our sense leads. But main negative will get the black, and then the very next positive will get the next white wire. And as always, guys, when you're messing with batteries, right, this isn't like a regulated power supply where if you short something out, there's a fuse, or if you short something out, there's only 5 amps or something like that. When you have a cell that is 272 amp hours and it's rated at, 2C for 60 seconds, if you short these terminals, you have an ungodly amount of current that is going to flow. And it is not regulated, is not fused. It's just gonna flow. So this is, vaporized tools kind of current.
And not joke worthy. I made a joke earlier and it was a bad idea.
My heart stopped. Yes, it's only 3.2 volts. Yes, I can just hold my hand across here. It's no big deal. But if you shorted it out, the current's gonna flow. And current is scary too. So watch out for that.
How does it compare to a wall, plugging in a wall socket next to it?
Well, first of all, a wall socket has usually a 15 or 20 amp breaker on it. So if you short it out too much, it's gonna break and then it'll be dead.
Gotcha.
It's also alternating current, which is a little different from DC because it has a 0 point, right? So you've got full positive voltage, full negative voltage, and when you're at that 0, say you're trying to, if you ever wanted to do this and make like an arc, if you want to make an arc on DC, the arc you can pull it out much longer because it's a constant current at a constant voltage.
Right.
Whereas AC, if you started pulling it out, that voltage 60 times a second or 30 times a second would hit 0, and so it would like extinguish the arc and then have to rebuild it again.
Gotcha.
This really isn't a topic for today, but that's one of the big things with breakers is if you're going to use a breaker for DC, you can't just go get any breaker.
Oh.
Because
right.
a breaker for AC is built to where it knows that it's going to hit that 0 point.
Okay.
And it'll break the, as you're pulling away, 30 to 60 times a second, and I should go look that up, but it will actually kill the current or the voltage drop and kill the arc, whereas with DC it doesn't happen.
Gotcha.
You will have that constant voltage across, and that arc will continue until it's extinguished. So DC breakers will have like a magnetic field inside the breaker to push the arc out of the way to break the arc. Rabbit trail, yeah. All the whites and the reds are positive, yes. And then one here and then one on the main positive. Of course, the one on the main positive, we might wait on that one because we probably want it on top of the big terminal.
Okay. And I think you were saying to me earlier that you wanted to zip tie these.
Yeah, this is exactly what I was thinking is what you're doing. It's just a logical.
Do we want to go on top of this?
Oh, that's true. There's the BMS terminal on there that we didn't get ready yet. Should we pause this?
We could leave it and zip tie it and
get the wire management done and then come back for the
and
terminal.
Just snug it.
I missed something here because we didn't get the lugs on the BMS yet. Are they hitting the insulation? Is there any way you can pull it out a little bit, or is it? Yikes! Caught on. It's like it's getting caught on the stud itself. Yeah, do that.
I'm gonna grab the torque and just see. Just give it some slow turns and see what it does.
Yeah, see if it pulls it down. It's flat now.
Did you already set this torque to the spec?
No, it's actually at 0.
Okay. And what is our torque gonna be?
So we're gonna hit about 40 inch-pounds. Sorry, these are inches. Go a little bit further because 35. If you hit the 0 on 35, back up just a tad. Put the 0 on 35, so you can see that's lined up with 35 right there. So then you want to go 10 more for 40.
Ah, gotcha.
Yep. And just put that 10 on the line, and then that'll be 40 inch-pounds.
So
Inch-pounds, not foot-pounds. Inch-pounds.
Inch-pounds.
And this is gonna feel like it's not a whole lot of torque.
It's gonna click, right?
Yeah.
I haven't used this specific.
There you go.
So that should be about right there. So
40 inch-pounds should be well within range for these, not to strip out the aluminum, because of course the studs themselves are aluminum. Not the studs. But what the studs screw into, the terminals of the battery are aluminum. And of course these studs are what, stainless steel, so obviously they're going to outlast the aluminum. And then yeah, just throw some zip ties on there to keep things tidy. Makes it a nice little package.
So positive and negative we're not putting on.
Right.
And I started here, that one's at 40, so I'm gonna come back to this one.
Did it get on the insulation? Yeah, it's sitting on it.
Is that bad?
Yeah, because we really want a clean contact between the nut and the ring terminal without having any insulation in the way. It's a little frustrating. I didn't think it was going to do that. Considering they're made for M6, you would think that they would work for M6 nuts.
So that's what it did right there. You see that crushed
Yeah, that's not
So now
good.
you don't like that plastic stuff you don't like?
Yeah, we don't want the plastic in the way, so it's going to mess with our, I imagine that would mess with our torque reading. I mean, for a sense terminal, I suppose it's probably not a big deal because you're not looking at high current, but it could loosen up over time. So we might just not use, these in the future, the insulated ones. We might just use the bare crimps, the bare ring terminals.
And that crushed it out of the way. I mean, it's gonna take an extra step to get it.
You always just, yeah, you could trim if they extrude too far, you can trim them back.
So, and this one we may get lucky. That one looks like it's not gonna do much.
Okay.
How you feeling that one? Do you feel like it's crushing it anywhere? No, I think it's clear.
That looks good.
So I just need to torque this last one there, and that'll be it for the torque.
Dare I say that we're ready to drop it into? Nope. We haven't cut the wires yet. Or the zip ties. That's important.
It's very important.
It's also very important to not short something out right now.
And that's why you have your brother who's very safety conscious here to remind you of this. Okay, so what's your idea for this? Because the BMS is going to be right here, right?
Yeah. So
this is going to come around this and down.
we'll have to see. We'll have to see once the BMS is in there. It's probably going to be pretty tight.
Okay.
Getting back over there, and we'll probably just have to manage the
so we can
the
do
wires
these.
that are longer. You might be looking at this going, why didn't you trim the wires so that they would all be? There is actually a thought behind that. If the wires are all different lengths, then you're getting slightly different voltages that you're sensing on the cells, which is why I leave them all the same length. That might be a wives' tale. I haven't tested it. I don't know of a really good test scenario for that. So one thing we will do once it's all in and the BMS is in place is we'll probably run this temperature sensor. What I've done is run it up onto the loom here somewhere, just so it's up close to all the battery cells.
Oh, okay. So maybe we could have waited on the zip ties till then, maybe next time.
But I don't think it'll have enough length to go all the way over anyway. So you're probably gonna have to come up and over. So I don't see it as a loss.
All right. So what's our next step, sir?
Why don't we drop it into the case? I feel like it's time to see it in. These should slip right into our ribs here, which will keep things in place. If this was a metal container, I would definitely put something in the bottom to make sure it doesn't short out the cells if they ever rubbed on it. But we're plastic on the bottom, so no big deal. Now we find out if it fits. Well, it seemed to have dropped to the bottom. Does it seem secure?
Little 1/8 inch gap there. This is snug. Got a little gap.
If I was
there.
a better carpenter, I would cut these at the right angle so that they would fit just right. So how about, does it close? I feel like that's an important item too. Seems like it. Fantastic. So I think the next piece is going to be the BMS. We need to get some leads crimped onto our battery minus and our charge minus. So if you don't know what a BMS is, this is a battery management system. A little bit better than a protection board. It has Bluetooth capability, right? So you can monitor what's going on instead of just knowing that something's wrong because it turned it off. The positive, as y'all have already seen, runs straight from your terminal through your 4-gauge wire over to the battery itself, or the last cell in the series. The BMS is going to interrupt the connection between the negative on your battery down to your negative terminal. So that allows the BMS where if anything is out of range, whether it be temperature or voltage or current or user defined, because you told the BMS to turn off, it will interrupt between negative and negative. That's why you've got this runs to the battery, this runs to the negative terminal of the case. You also have the temperature sensor lead, which is really important for these lithium iron phosphate batteries. And the reason for that is that if you try to charge one of these lithium iron phosphate batteries and it's less than freezing outside, you will permanently damage them. You can discharge up to like -20 Fahrenheit, I think, for these cells. You can go look up the spec sheet on those. But charging, you don't want to do at less than 0. So by default, these are set up for lithium iron phosphate, and they're set up for a 0 or a -2 Fahrenheit cutoff. So if the temperature sensor gets below freezing, it will not charge.
I just cracked
Oh no.
this housing.
Note to selves, these will crack.
So probably need to replace that one.
Go check my toolbox, because I think there's extras. Back it up, back it up.
How many times did you put this together?
At least 3. It's not a project if you have to do it only once.
No, it's not. Well, luckily, we found some replacements.
Yeah, I've done a few of these, and for whatever reason, I guess I didn't use this piece in one of my builds, and I just happened to have it in a toolbox that was here. So we were fortunate today. That's actually one of the complaints people have about these, if you go look at the reviews, is like, it's brittle and it broke. And I'm like, I never broke one. I'm usually pretty light on the wrench. Unlike, Caleb's not. He is not light on the wrench. So we might go with a kind of like, if it starts squeaking, it's tight enough. Something along those lines. I don't know.
I could do that.
It's an audible indicator. Audible indicator.
I was going for the third squeak.
Oh, third squeak. Okay.
But that was too far, so we could probably go with 1 or a
So 1 gives us a 1 squeak buffer. If you ever wanted to do a 24-volt version of these, I don't have a good box yet. But obviously, it's just adding 4 more cells. So just, longer threaded rod. Different BMS. It's a great drop-in replacement for RV batteries, because most of your leisure batteries that might be like 100 amp hours.
So I wonder if this is a different build, because I'm having a harder time catching it to...
Oh, really?
It's spinning a lot.
Spinning easier?
Yeah, it's spinning easier. That's still enough thread there, right?
Yeah, I think so.
How do you feel about me grabbing this with some pliers?
If you did it real lightly, it might be fine.
Oh, you hear a little creak there, maybe?
Yeah.
I guess the test would be to put this on there. See if it rotates. No, I think we're good. Nope.
No bueno.
Right here.
Last thing we want is to have to take it apart after a customer uses it and it loosens up on them.
Okay, we're breaking out the pliers. We gently. So goodness, it squeaks there. I'm calling
It
that.
sounded like a squeak.
It sounded like a squeak to me.
That was a 1 squeak.
So I guess the next test will be to see if we can get this on here. There we go.
So now what'd be fun is getting that connected. So the BMS is gonna sit right up in here somewhere, probably between the all thread and our positive wire. But then we're gonna have to connect the BMS to here and then up to here. Our 2 terminals. Let's get our terminals crimped. We're gonna do some stripping. B- will go up to the battery, so main battery negative. The C- is the charge minus, and that will go to here.
Okay.
The other side of here.
And then the rest of these, we're talking about later.
It'll be all 3.
All 3.
This is
Gotcha.
1.
Okay, so which?
So this is a 4-gauge 3/8, which is for that terminal there, and then this is a 4-gauge 1/4 inch.
Is that right?
Yes, that's right. 1/4 inch to the battery, 3/8 to the terminal.
Okay, gotcha.
But they're both 4-gauge, which is what we need for. Apparently, 4-gauge works well for, what is this? These are 10-gauge wires, and there's 3 of them. So 3 10-gauge wires fit fairly well in a 4-gauge crimp.
Okay.
So we'll just need to strip them back. And these are a little more awkward because you're trying to put 3 wires into 1 terminal. You might, in my experience, do it a little further than that.
Okay.
And we'll end up with some metal
exposed,
but with 3 of them, it's really awkward trying to get all 3 of them in there. And having some extra can be helpful. Yeah, if y'all are wanting to build your own, we'll throw all the links to the tools we use, as well as the products and battery and all that stuff. The all thread, I mean, that was just Home Depot, of course, and that was 5/16 18 pitch thread. And then I just grabbed 5/16 nuts and some 5/16 washers for that piece of the assembly. And then of course this is just, I believe this is 1/2 inch plywood. This isn't 3/4, so it's got to be 1/2 inch or 15-30 seconds, something like that for that piece. These guys were off of Amazon, the terminals themselves. The heat shrink M6 22 gauge terminals, that was off of Amazon. They were Wi-Fi. BMS I did grab from AliExpress, and the cells were from Alibaba. If you're local here in the area and would rather buy them off of us, let me know. Most of my tools are from Amazon because I'm an Amazon addict and just order it from there. And that's where, I mean, these lugs and everything. I mean.
So C is going to the terminal.
Yes,
and
sir.
B is going to the battery.
Yes, sir.
The 4 gauge?
Yep.
1/4 inch is going on this one here.
Yes, that's right, because that one's going up to the batteries. So this tool is fantastic. I had a manual crimping tool, and it had like, you know, 4 sizes, and you're like, oh yeah, just use one of these sizes. It was just the worst waste of money I have ever spent. This has a whole set of dies, everything from what, 10 gauge here, all the way up to, oh my gosh, how big is this? What is that, 600, what does this say? 600 MCM, I don't even know what that is. It's big. This thing will last us years.
So I'm gonna walk through this to make sure I got this right.
Yep.
So I've got the 1/4 inch 4
Yep.
gauge, which is gonna be for the battery.
Yes, that would be battery
Which is
minus.
C, minus C.
Nope,
Nope, minus B.
B for battery.
Okay, so thinking through how this is going to fit, or lay, so we want this to lay here, and then this is going to come down.
Yeah, we're not really sure on the orientation, right? Like that would probably be, that's probably gonna be ideal, is
Put it
yes,
there.
because the BMS leads are coming in from this side.
Okay.
Oof, but that's hard because the charge minus, what if you flipped it upside down? Yeah, would that work?
So then this has to get to here though, right?
No, because this is B minus. This goes to the top.
Oh, I had it upside down. Gotcha. Okay, cool. Yeah. So these need to be facing down.
Where they're naturally at. How about that? These are fairly flexible, so I don't think it's too terribly.
These are tinted. These are soft.
Yeah, they're tinned on the end. If it gives us trouble, we can clip those off so that it's just bare wire instead of tinned wire. I think they tin them so that they don't fray for the most part. I think that's the main reason. It's supposed to make it easier on us.
They're cranking unless you see something that I'm doing wrong here.
Do you think they're all in there far enough?
I mean, I can't push any of them any further.
Okay.
I mean, I could pull them out and we'll see where we're at, maybe.
Can you? I think you're good. Yeah. I see how long they are now. My bad.
So I made them a little too long, maybe. Eh.
But that's okay. You got
We're gonna
shrink
put
wrap.
shrink on it. Okay.
That's what
All
shrink wrap is for. So this is a 120 amp BMS, and they have 3 10 gauge wires. So they're rating these 10 gauge wires at 40 amps a piece. But there's this thing where if you have wires inside of a device, so like inside an inverter or inside a charge controller or whatever, like for whatever reason,
Should we be worried about the fact that I missed that right there?
no, that's not worrisome, just those two. When you've got 10 gauge wire that's inside of a component, for whatever reason, it can be a higher amperage across it. And I don't know why. Maybe it's because it's always going to be a much shorter run. So like for these, you're only going a few inches as opposed to, you know, 5 feet or 20 feet or 500 feet. They've got these rated at 40 amps, but that's, I think it's reasonable. Now everyone could ignore me because I'm not an electrician, so I shouldn't be talking about it anyway. Definitely a risk when you're doing 3 different wires that, you know, one didn't get a good crimp, but it looks like we're good. They winged out, and that's probably winged out. They winged out. Probably because there's not enough wire in there, and that's not a fault of our own. It's just that we're dealing with 3 wires. The only other thing I can think to do would be soldering instead of crimping, but soldering is generally considered less reliable. It's brittle, so rattling around it could come loose, kind of a thing. I don't know. It's probably 6 of one, half a dozen of another. I think this is mostly just a cosmetic thing, the fact that they winged out. You'll notice that the other ones we did, which was the proper gauge wire with the proper gauge crimp, looked beautiful. With the BMS, right now the BMS is connected to nothing. You want to make sure that the first thing you connect is the negative terminal to the battery itself, and then we can connect the sense leads. But we're not even doing that yet because we need to make sure that the sense leads are connected correctly, and we can verify that electronically with a multimeter. So let's do that now before we forget. Basically what we're going to do is check black lead. We will connect to the negative of the multimeter, And then we're just gonna run down all of the other leads and make sure that it goes up by about 3.2 to 3.3 volts for every lead. Oh, there you go, 3.3. 6.59, that's good. 9.9, good. Then the next one should be around 12, 13 volts, good. So if we had one that was out of order and we didn't increase every time, that would tell us that we had something mixed up here. You will smoke a BMS. One of these I did connect something weird and it did not smoke it. I think I connected it reverse and it did not smoke it, which I was really surprised about. So they might have some protections that other BMSs don't, but you can definitely, I've smoked a balance board before by having the leads opposite. So positive was negative, negative was positive. I plugged it in and it just let out the magic smoke. So I always want to check that electronically before you plug it into the BMS, and they make this easy because they've got the black and the red that tells you what's main negative, what's main positive. So let's connect.
So quick question, if you're doing that, should you have the main positive and main negative connected?
Testing this.
To test it.
We should have had these probably attached better.
Okay.
But we got voltage off them, so it would be okay to connect the B- of the BMS up to the battery and to connect the positive wire up to the battery before you check the voltage on the sense leads. You just don't want to forget this piece.
Right.
So I got ahead of myself because I didn't want to forget this.
Yeah.
But yes, that could throw off the measurements if these aren't making good contact. So why don't we go ahead and connect the positive up. Typically I would run 4 gauge in here, I think, not 2 gauge, but that's what I had today. I ran out of my 4 gauge wire, so we probably usually have a little more flex in it than that, but I don't think that's a problem. Tighten this up to 40 inch-pounds. Inch-pounds, people. Don't grab your mechanics wrench and do to foot-pounds. You will break something. I bought this wrench back when I was rebuilding the traction battery in my 2007 Prius, and I had a lot of terminals on that battery to put together.
So it looks like we were okay on the shit.
Yeah, so the insulation stayed out of the way.
Yeah.
So we're good. All right, so we've got positive, and as always, we're being careful not to short anything on this battery. So we should now be able to, I suppose it doesn't matter whether we connect the charge or the battery first. So we probably want to connect the charge first over here before we stick the whole BMS down there and not have a whole lot of access to it. Something that we do want to pay attention to, we don't want the BMS to like short out on either the positive or the negative terminal. You're just upside down is all. So we want to watch out for that. That positive terminal is nice and far down there, thankfully, so we shouldn't have a problem there.
See, I got this on good, but I forgot to put the washer.
I commend you, sir, for taking it apart to put the washer back on.
Well, that's what I was told to do, so I have to do it the right way.
Washer, ring terminal, washer. Nut. What was this, like a 17 you said?
Yep.
17 millimeter. They have these terminals up front in 3/8 and 5/16. I always go with the 3/8. I used some 5/16 once, and running 100 amps through them, they did get warm. I figured it doesn't hurt me much to go 3/8. They're a little bigger and beefier. We gotta tuck that BMS down a little bit and get our negative terminal on, I guess. I think it'll go down there. BMSs will get warm. You got MOSFETs in there that are powered, that are allowing current through. You don't want batteries to get warm. They're gonna get warm, right? But you wouldn't want them to get warm unevenly. So preferably, we don't want a BMS sitting right up against the battery. So what I've used is just a piece of foam or something to just kind of insulate that. I've run these BMSs at their rated current and they don't get extremely hot. In addition to that, for something like this, running at 120 amps, you're only gonna run for 3 hours before it's depleted. So most people aren't gonna do that. Usually you're gonna have a battery like this, and it's a solar storage battery, which means you're running for 8 to 12 hours to discharge it. And if you're running at 120 amps, it's not going to be for very long. So I'm not super worried about heat buildup in the BMS because I haven't seen that as a problem with these BMSs. You think we should hot glue it on there? Wouldn't hurt,
the BMS?
Right? I'll just glue it onto the BMS that way. That was our tool purchase of the day. We got down here and I was like, oh man, I forgot the hot glue gun. I want to see Grandma out there with her cordless 18-volt Ryobi doing crafts. Honestly, one of the main things whenever did use a hot glue gun was the cord was obnoxious because the glue gun weighs like 5 ounces.
And then also it falls over. With the battery, you set it down. It's not falling over on you. That takes a long time. I think we've turned it on well before we've done it every single time.
I guess we could probably go ahead and
Can we get that on, you think?
And then come back and glue the foam back in. So right now, if we measured between this terminal and this terminal, we'd get 13 volts. So main negative, main positive, 13.19. Measure from here over to our negative here. You'll notice that it's not 0, but it's not the 13.2. The BMS lets some current, some voltage through, but you wouldn't actually be able to pull any current off of that. BMS is off. Once we have the BMS sense leads connected and we turn the BMS on, then we'll get 13.19 straight to the terminal on the outside case, which is through the BMS. Probably just zip tie that up somewhere.
Do you want this up on high? Or
it doesn't matter,
so we
really.
Yeah,
we could just do like that. I've done that before.
Okay.
So we can now connect those.
Do we need to connect this up first?
No, it's just, but we do need to run it and zip tie it in along with this. But
I wonder if I should have done this before I dropped this in here.
Right.
Okay, so I'm looking for the hooks on top. There we go.
I was thinking it was gonna be further over, but yeah, if you want to just run it to like right here or something, I think that'll be fine.
It's in here somewhere.
Yeah, it's just measuring the temperature of the battery. So if this temperature sensor gets below freezing, we just want it to be representative of the battery. Oh, held it for that long and then I let go. Here, watch out. Sorry. You were just trying to get it on there so that you could do it.
Yeah, it's all good. Will we want to attach like right here or just?
Yeah, I would do that just so that it's not vibrating as much. Anything we can do to keep things, I think, more rigid would be better. Is that everything?
I feel like that might be everything.
I think that's, well, no, you've got 3 zip ties to trim.
Excuse me. That's
Sorry.
why I've got these in my
Yeah,
hand.
I realize you've got those in your hand. I'm just surprised you didn't yell at me first. We need to get Caleb some side cutters.
I've got a nice pair in my toolbox.
Oh, do you? Okay. All right. So, beauty of these BMSs, I've got some other BMSs that are a little more difficult to activate. And so once you get it all connected, you have to either apply charge to the terminals, or you have to like plug in a wire and use a 1.5 volt battery to short it out, anything under 12 volts, and then it'll turn on, and then you can connect to it. With this one, we've actually got this app on the left. Actually, either of these apps will work. On the iPhone, I like this one on the left, but the one on the right is also available on Android. So if we fire that up, we will immediately see a BMS available, and we can just tap on that. We can see that it's showing a 60% state of charge, 13.2 volts. I mean, it's the parameters aren't set yet, right? Because it's showing 60 amp hours out of 100 amp hours, and that's really just it's using the voltage, the resting voltage, to see what kind of capacity it has, which is relatively inaccurate. You can see the BMS was manufactured in January, nice and new. But the main thing is, it is actually on. So we can also go turn it off, which I think is a really cool feature for having a battery like this, because if you're ever transporting it or putting your RV away for the winter or something and you want to just turn everything off, you can actually do that. So you can see the charge and the discharge are off, and it'll tell you why. The MOSFET software locked. If one of the sense leads came disconnected, or one of the cells in the battery got to too low of a voltage, you'll see a different alarm here, like a low voltage or a high voltage, or low temperature, high temperature, over current. That's going to tell you why the battery's in the state that it's in. But yeah, just turn it on. In order to get into this app and read the information and set the information, you have to pay for this portion of the app. I think it's like $5 or something. So anyway, so you can come in here and do the BMS read. This will give you all the values that it's set to right now. So like you can see the 100 milliamp hours. So this one's at 272,000 milliamp hour. So in order to change that, I would set that, and then I would do a BMS write, confirm. And then if we go back to here, it'll now show that it's at 60 out of, oh, yeah, it changed, right? Because it's a percentage, it's at 60%. So it's at 163 out of 272 amp hours, supposedly. That's just based on the 13.2 volts. We did not top balance these cells. So they're all sitting at about 3.3 volts. Now, one or two of these cells, or all of them, could be at totally different states of charge, even though they're all showing about the same voltage. And that's because they're very flat discharge curve with these cells until you get to right at the top or right at the bottom of their capacity. So what we would do now is hook this up to a charger, preferably, you know, for this first bit, you could hook it up to something fast, 20, 50, you know, 100 amps. You could charge these at 100 amps, it'd be fine. But then once you get very close to full, if you stick it on like a 1 amp charger, it'll allow the balancer to kick in and get all of the cells within balance. It'll also happen over time by itself. The balancer is turned on by default if you come in here and do your BMS read. By the way, here's that cell 60% capacity voltage, 3.3 volts. So that's what it's basing the capacity on right now. It's saying it's 60% because you're at 3.3 volts per cell, which is right where we're at. Balancer configuration. So once the cells reach 3.4 volts apiece, the balancer will kick in as long as there is at least a 0.1 or a 15 millivolt difference. So that would be 0.015 volts. If any cell is more than 0.015 from any other cell, then the balancer will start. Now it'll only happen when charging, according to this setting here. And that keeps you from just having the cells fighting each other when you're not charging, and that could just run the pack down. So if you're just trying to get a pack balanced from the get-go, you might disable that for the moment, but for just running a pack in general, I would just leave that enabled so that it's only balancing when charging. So lots of settings to go through in here, and now we have a nice Bluetooth app for our battery, and we should now be able to see, now that the battery is on, that we have voltage, full voltage on these terminals here. $13.19.
There we go.
All right, well, I'm taking this. Do you need anything?
No, guess that's it.